Now we'll discuss about generator protection. A modern generating set is generally provided with the following protective schemes. That is stator protection, rotor protection, miscellaneous. Stator is percentage differential protection, protection against stator interturn faults, stator overheating protection. In rotor protection, field ground fault protection, loss of excitation protection, protection against rotor overheating. And in miscellaneous, over voltage protection, over speed protection, protection against motoring, protection against vibration, bearing overheat protection, protection against auxiliary failure, protection against voltage regulator failure. First is stator protection. So the percentage differential protection, it is used for protection of generator above 1 megawatts. It protects against winding faults. This is also called bias differential protection. The polarity of the secondary voltage of current transformer is at particular moment for an external fault has been shown in the figure. So here you can see in the diagram current transformers and bias coil, operating coil, percentage differential protection for external fault condition. For internal fault, the polarity of the secondary voltage of the upper current transformer is reversed, shown in figure 2. So the upper operating coil carries the sum of currents sent by the upper current transformer and lower current transformers. The percentage differential protection does not respond to external faults and overloads. It provides protection against ground faults to about 80 to 85% of the generator windings. So in case of stator faults, the tripping of circuit breaker to isolate the faulty generator is not sufficient to prevent further damage, as the generator will still continue to supply power to the fault. Restricted earth fault protection by differential system. So when neutral is solidly grounded, it is possible to provide the protection to complete winding of the generator against ground faults. See here in the diagram you can see the percentage of unprotected winding against the phased ground fault. So the winding is protected and the P percentage of winding is unprotected. It can be seen that relay setting of the differential protection is determined by the value of neutral grounding resistor and percentage of winding is to be protected. So here the ground fault IF is given by P by 100 in P by Rn. V is the line to neutral voltage, Rn is the neutral grounding resistance. This is the percentage differential protection for a Y connected generator with only 4 leads. That is when neutral connection is made within the generator and only the neutral terminal is brought out, percentage differential protection can be provided. So you can see in the diagram, the scheme protects the generator winding only against the ground faults. It does not protect it against phase faults. Protection against stator intern faults. So here is the diagram, that is transverse percentage differential protection for multi-winding generators. Here the longitudinal percentage differential protection does not detect stator intern faults. A faster and more sensitive split phase protection is shown here. So here the single current transformer having double primary is used. So no bias is necessary because of common current transformer is employed, so that errors due to current transformer differences do not occur. This is the intern protection based on zero sequence component. So if the generators do not have access to parallel windings, a method based zero sequence voltage measurement can be employed. Figure 7 shows the schematic diagram of intern protection by zero sequence voltage measurement across the machine. Next is the stator overheating protection. So modern generators employ two methods to detect overheating, both being large generators above 2 megawatts. First is inlet outlet temperatures of cooling medium. Two is the temperature sensing elements are embedded in the stator slots. So here is the stator overheating protection diagram. So here they are embedded in the stator slots in the different locations. So when the temperature exceeds certain preset maximum temperature limit, the relay sounds an alarm. This is the rotor protection. Here field ground fault protection. So that is a DC voltage is impressed between the field circuit and earth through a polarized moving iron relay. So in case of brushless machines, the main field circuit is not accessible. So a severe fault or short circuiting of the diode is detected by a relay monitoring the current in the exciter current control circuit. Loss of excitation. So when the excitation of the generator is lost, it speeds up slightly and operates an induction generator. So the rotor of salient pole generators are not overheated because they have damper windings which carry induced currents. Stator overheating does not occur as quickly as rotor overheating. Next is the protection against rotor overheating because unbalanced three-phase stator currents and a typically time range of relay 0.2 to 2000 seconds. It has a shaded pole construction with metal shunt. So the alarm unit also starts a timer which is adjustable from 8% to 40% of negative sequence component. So here protection against unbalanced stator currents diagram is shown here, which has generator windings and overcurrent relay, which has a negative sequence filter also along with the current transformers. Miscellaneous overvoltage protection, that is the overcurrent, that is overvoltage may be caused by defective voltage regulator, and overvoltage relays are provided with hydro and gas turbine sets. Overspeed protection, that speed governor normally controls its speed. It is designed to prevent any speed rise even with 100% load rejection. Protection against monitoring, when the steam supply is cut off, the generator runs off as a motor. If a protective relay is required for protection of the steam turbine. Next is the protection against vibration and distortion of rotor. Here the vibration is caused by overheating of the rotor or some mechanical failure may occur. Bearing overheating protection. Temperature of the bearing is detected by inserting a temperature sensing device. Protection against auxiliary failure, that means high grade protective equipment is employed for their reliable operation. For large generating sets, protection against loss of vacuum and loss of boiler pressure are provided. Protection against voltage regulator failure. So here they are subject to component failures. A definite time DC overcurrent relay is provided with which operates when there is overcurrent in the rotor circuit. Protection against pole slipping, that is in the case of system disturbances after the operation of circuit breaker, and that is generator rotor may oscillate. Some oscillations may disappear in a few seconds. So if the disturbance is over, the generator may regain asynchronization. So if it does not, it should be tripped. Thank you.